Hello friends, most welcome to my YouTube channel Maths by Samit Deshmukh. So please subscribe the channel if you are new on my channel and hit the bell icon so that you will get the notification of newly uploaded videos. So in this video we are discussing the example from miscellaneous exercise first. So already we know that question number first from every miscellaneous exercise is multiple choice question. So let us try to solve the first example. So in the first example, observe the given condition. P and Q is false. What is the condition? P and Q is false. And second condition is P or Q is what? True. Using this we have to check which of the following statement is not true. Not true means what? Which of the following statement is false. Now here it is given to us that two statement means and of two statement is false means at least one of them is false, and or of these two statement is true means at least one of them is true. Means what result we are getting here? P and Q are true statement, at least one of them is true and at least one of them is false from the given condition. Means if P is true, Q is false. If Q is false, then P is what? True. These conditions are satisfying. At that time only we are getting these result, isn't it? Now we have to check which of the following statement is what? Not true means false. It is already given to us that P or Q is true. Now double implication. We know that double implication is false only if truth values are not identical, and in this case truth values are not identical, and in this case also truth values are not identical. That's why we can say that B option will be the correct answer here. Now observe the next example. P and Q implies R is logically equivalent to. Here two parts are connected by what? Implication. And in case of implication you should have to remember this result that P implies Q is equivalent to. So it is equivalent to what? Negation P or Q, which is also called as conditional law. But if you observe the options are in terms of what? Implication. So you should have to know another result also, that P implies Q is equivalent to negation Q implies negation P. Negation Q implies negation P is nothing but contrapositive of P implies Q. Means simply remember that implication is equivalent to its contrapositive. And what is inverse of this statement? Converse of this statement is Q implies P, and converse is always equivalent to inverse, means negation P implies negation Q. So remember this result, that implication is always equivalent to its contrapositive and converse is always equivalent to what? Inverse. And we have to make the utilize of this result in this example. So let us begin with this given option. So here and is replaced by what? Or. So definitely if and is replaced by or, truth value varies, means this statement cannot be equivalent with this statement. Now if you will observe the second, if we are taking its contrapositive, so contrapositive means negation R implies, so negation R implies negation of P and Q, and negation of P and Q means what? Negation P or negation Q. लेकिन पहले ये आना चाहिए था, बाद में ये आना चाहिए था, तब जाके हम बोल सकते थे कि this new statement will be contrapositive. But here contrapositive, this statement is not contrapositive, so this is also false. And here and this first side they have keep it as it is, only they have used negation in the second part, and this option also does not satisfy any of the condition. That's why we can say that this statement is also what? It cannot be logically equivalent with given statement. Now possibly is that first statement is true, but here using this result we are not able to conclude that A option will be the correct answer. In such cases, if these laws are not applicable, at that time second way to check whether statement are logically equivalent or not is just simply constructing its truth table. So PQR are three statement under consideration. So let us try to find out truth value of first part, P and Q. So we have to connect these two statements by and in case of and, at least one statement is false and will be false. So true, true. In the first two cases we are getting true, then false, 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 means for remaining all cases we are getting what? False. Now this P implies Q implies to P and Q implies to what? R, means P and Q implies to R. These two statements we have to connect by implication so that we will get truth value of first statement. Now in case of implication, if TF appears, at that time only implication is false. So here TF does not appear, so it is true. Here TF appears, so it is false. And if first statement is false, implication is always what? True. Not necessary to check what is the truth value of second statement. In this way, we have got the truth value of first part. Now let us try to find out truth value of this statement, Q implies R. So Q implies R means we have to connect these two statements by implication. Let us check where TF appears. If TF appears, at that time only implication is false. Here true is there, so true. Here TF appears, so implication is false. TF does not appears in these three cases, so true. Again TF appears, so false. Here TF does not appear, so true. Now P implies to Q implies R. P implies to Q implies R. So here TT is there, so true means we are getting truth value of this statement. So here TF appears, so false. Here TF does not appears, and here first statement is false, so implication is true. Means in remaining all cases we are getting true, and we are easily able to observe that truth values are identical, so that's why we can say that these two statements are logically equivalent. Now see the question number 3rd. In this example, we have to find out inverse of this statement pattern. If you observe the statement pattern, two parts are connected by what? Implication. Means it is in the form of P implies Q, and we have to find out its inverse. Inverse means what? Just simply use negation in the both part. The new statement which you are getting, it's called as what? Inverse of the given statement. So observe this statement. To find out its inverse, we have to take negation in both the part. Means negation of P or Q implies negation of P and Q. Just we have used negation in first part also and negation in this second part also, as we are finding inverse of this statement. But such type of result does not appear in this example, so that's why we are simplifying it. So here use the rules of negation. Whenever we are applying negation on the bracket, replace every letter by its negation, or by and by what? Or. So what result we will get here? Negation P, or will get replaced by and negation Q. Implication, keep it as it is, apply this negation, so negation P and will get replaced by or negation Q. So we can observe this result in option number C. So that's why here we can say that C is the correct answer. Now observe the example number 4th. In this example, it is given to us that P and Q is false, means at least one of them is false. At that time we can say that and will be false, and even it is given to us that implication is also false. But we know that implication is false means definitely first statement is true and second statement is false, means P is true and Q is false. Using this we have to find out truth value of P and Q. So we know that if P is true and Q is false, at that time only implication is false, and for this truth value P and Q is also what? False, means this truth value satisfies both the condition. Now see the example number 5th. In this example, we are finding negation of inverse of this statement. Means to find out negation of inverse means we have to find out inverse of this statement, and later on we have to find out its negation. So here solution of this 5th example is we are finding negation of inverse. Whenever we are finding inverse of implication, means whatever the statement is given to us, in both the part we are using negation. In the first part, if we are writing negation, means negation of negation P will become what? P implication as it is, and in the second part also we are using negation. Means whatever the statement is given to us, in both the part if we are using negation, means we are finding inverse of that statement. Inverse is known to us. Now we are finding negation of this inverse, and for that purpose you should have to know the result. Negation of P implies Q is what? P and negation Q, means don't disturb to first part, then write down which logical connective and use negation in the second part. Means here don't disturb to first part and keep it as it is, and use the negation in the second part. Means negation of negation Q will become what? Q. Means we can say that P and Q can also be written as what? Q and P. So will be our required answer. Now observe the second statement. Here we are finding negation of this given statement. So negation of P and Q implies R. So here two parts are connected by what? AND. So first we are applying negation on AND means what? Conjunction. In that case, replace every letter by its negation. So first letter also we have replaced by negation, and will get replaced by OR, and second part also we are replacing by its negation. So whatever the second part is there, we are replacing by its negation. Now keep the first part as it is, or also as it is. Now we are applying negation on this implication. Whenever we are applying negation on the implication, keep the first part as it is. First part means Q as it is, then which logical connective is there? And use the negation in the second part. Here second part is R, so we have used the negation in the second part. In this way we have got negation of the given statement. Negation P or Q and negation R appears in this option, so this will be the correct answer here. Now observe the example number 7th. In this example, element of set A are 1, 2, 3, 4, 5. Then which of the following is not true? Not true means what? False. So let us check the first option. There exists x belongs to A such that x plus 3 is equal to 8. X plus 3 is 8 only if x is 5, and yes, 5 appears in this element, in this set. That's why we can say that first option is true, because there exists means there exists at least one element which satisfies this condition, and yes, 5 exists in the set A which satisfies this condition. So for first statement, truth value of first statement is true. Now check the truth value of second statement. There exists at least x belongs to A such that x plus 2 is less than 9. Let us check whether at least one element satisfies this condition or not. If I am replacing x by 1 plus 2 is 3. Yes, 3 is less than 9 means at least one statement satisfies this condition, means statement is true. Now for every x belongings to A, x plus 6 is greater than or equals to 9. Means every element of set A should have to satisfy this condition. At that time only we can say that statement is true, because for every means let us check every element satisfies this condition or not. So directly I am using 5 here. 5 plus 6 is what? 11, and 11 is greater than or equals to what? 9. But if you are taking x is equals to 1, 1 plus 6 is 7. 7 is not greater and neither equal to 9, means first element does not satisfy this condition, means this statement becomes false. So, and question is also to find out what? Which of the following is not true? Not true means what? False. In this way we have solved all the examples from question number first. Now we are starting question number 2. Now see in the question number 2, what is the question? Which of the following sentences are statement in logic? Justify and write down the truth value of the statement. Means here two parts are there. First we have to check that the given sentence is statement or not. When we can say that the sentence is statement, if we are able to identify it is true or false, but both true and false should not be simultaneously. If we are able to check that it is true or false, then and then only we can say that it is what? Statement. Means we should have to identify the truth value, either it is true or false. And in case of statement we have to write down that truth value. So let us start with the first example. 4 factorial is equal to 24. Now what is the meaning of 4 factorial? 4 factorial means multiplication of first 4 natural number, means 1 into 2 into 3 into 4. And here we can observe that 4 3s are 12, 12 2s are 24, means yes, multiplication of first 4 natural number is equal to 24, means it is a statement, because we are able to identify whether it is true or false. And what is our result? So it is a statement which is what? True, which is true. And since it is true, that's why we can say that its truth value is what? T. So in this way we have got the truth value of the first statement. Now in the second statement, pi is an irrational number. Already we know that pi is irrational number because its decimal representation is non-terminating and non-recurring. But generally we are taking value of pi is equal to 3.14 or 22 by 7. It is approximate value, but its decimal representation, if you will observe it is non-terminating and what? Not recurring. That's why we can say that it is statement which is what? True, because pi is what? Irrational number. It is true, and that's why we can say that its truth value is T. Now observe the third sentence. India is a country. Yes, India is a country. It is true part, means first part is true and second part is connected by what? And. Himalaya is a river. So we know that Himalaya is nothing but mountain. It is not a river. So second part is false. And in this case, which logical connective appears? And in case of and, if at least one statement is false, and will be false. Means here we are able to identify the truth value. That's why we can say that it is a statement, but its truth value is what? False. Its truth value is false, and truth value we are denoting by what? F. Hence we can say that its truth value is F. Now observe the next sentence. Please give me a glass of water. It is nothing but a request, and we know that request cannot be a statement because in this case we are not able to identify whether it is true or false. Now see the fifth one. Cos square theta minus sin square theta is equal to cos 2 theta. Yes, we know that it is double angle formula. Cos 2 theta can be written as cos square theta minus sin square theta for every theta belongings to what? Real number. So we can say that it is a statement which is nothing but what? True. And since the statement is true, so we can say that its truth value is T. Now observe the next sentence. X is a whole number, and then x plus 6 is equals to 0. If x is a whole number, then its value is what? 0, 1, 2, 3, 4, 5, 6, continuing this way. These are what? Whole numbers. And for whole numbers, let us check whether this condition is satisfying or not. Means x plus 6 is equals to 0. Addition of these two numbers is 0 only if this first part is what? Means x is minus 6. At that time only this addition is what? 0. But x is equal to minus 6 does not belongs to what? Whole number. Means there does not exist a single whole number for which the addition of these two number becomes what? 0. Because the addition of these two number becomes 0 only if x is equal to what? Minus 6, and minus 6 does not belongs to what? Whole number. That's why we can say that it is a statement which is what? False. Because they are saying that for x, if x is a whole number, then this addition is 0. For any whole number, this addition cannot be equals to 0. That's why we can say that it is a statement because we are able to identify its truth value. And what is its truth value? False. And truth value is denoted by what? F. Statement is false and truth value is denoted by what? F. In this way we have completed question number 2 of this miscellaneous exercise. Now see the example number 3. In this example, we have to write down the truth value of the following statements. Some statements are given to us and we have to write down truth value, or we have to find out the truth value of the following statement. So let us consider first example. So here root 5 is an irrational number, but 3 root 5 is a complex number. So this is the given statement. If you'll observe here very carefully, two parts are connected by but. But means what? And. But is alternate word which is used for and. So let us denote the first part by P, that root 5 is irrational number, and the second part 3 root 5 is a complex number by Q. Now we are finding symbolical representation of this statement, and here we can observe that these two parts are connected by but. First part already we have denoted by P, but means what? And second part we have denoted by what? Q. So we have got symbolical representation, symbolic form of given logical statement. Now we are finding truth value of first part. What is the first part? That is P. Root 5 is irrational number, and we know that root 5 is irrational number means we can say that truth value of P is what? T. Now find out truth value of Q. 3 root 5 is a complex number. We know that 3 root 5 is also what? Irrational, and irrational number belongs to what? Real number. And we can say that 3 root 5 is a complex number is what? False here. So 3 root 5 is a complex number is what? False, because it is a real number. Now truth value of this statement, we have to find out truth value of this statement. So in here two statements are connected by and in case of and, if at least one statement is false, and will be false. Means truth value of P and Q is false, and P and Q is the symbolical representation of what? Given statement. Means in short we can say that truth value of given statement is false. Now let us start the question number 3. In this question we have to write down the truth value of the following statement. Some statements are given to us, and we have to state the truth value of the given statement. Truth value means we have to check whether it is true or what, false, means T or what, F. So let us see the first example. Here root 5 is an irrational number, but 3 root 5 is a complex number, means two parts are connected by what? But means what? And. But is alternate word for and. So we are denoting first part by P and second part by what? Q. So what is P here? Root 5 is irrational number, is P, and second part 3 root 5 is a complex number, we have denoted by Q. Now we are finding symbolical representation, means symbolic form of this logical statement. This first part already we have denoted by P, but means what? And this second part we have denoted by Q. In this way we have got symbolical representation of given statement. Now we are finding truth value of first part. What is the first part? Root 5 is irrational number. Yes, we know that root 5 is an irrational number, so we can say that its truth value is T. And second part Q, 3 root 5 is a complex number. 3 root 5 is what? Is also irrational number, but irrational number belongs to what? Real number, and we know that every real number is what? Complex number. Every real number can be expressed as A plus BI. Here term of BI does not appear, means imaginary part does not appear. Its meaning is that coefficient of I is what? 0. And even just simply remember that every real number belongs to what? Complex number. So this is real number, and that's why we can say that it is a complex number, because already we have studied that every real number is a complex number. So we can say that the second statement is also what? True, that 3 root 5 is irrational. Irrational means it is real, and every real number belongs to complex number. So truth value of second statement is also true. Now we are finding truth value of given statement. Given statement it in symbolic form can be written as what? P and Q. Means if we are finding truth value of P and Q, means indirectly we are finding truth value of given statement. So that's why we are writing here truth value of P and Q. In case of and, if at least one statement is false, and will be false, but here both are true, so that's why we can say that truth value of P and Q is what? True. Now observe the second statement. For every n belongs to n square plus n is even, while n square minus n is odd number. So first part we have denoted by P, and the second part we have denoted by what? Q. Now we are finding symbolical representation. If we are replacing here while by and, the meaning of the statement does not changes, that for every natural number, every n belongs to natural number, n square plus n is even number, and n square minus n is an odd number. Means if we are replacing while by and, meaning does not changes. Means we can say that here symbolical representation of given statement is P and Q. Both parts are connected by what? And. Now to find out truth value of P and Q, truth value of P and Q means truth value of this statement. First find out truth value of P and truth value of Q. Observe the first statement. So here n square plus n, means here two possibilities are there. Either n is what? Even or odd. In the first case n is even. We know that if even number is there, then its square is also what? Even. And addition of two even number is always even, means we can say that truth value of P is what? T. Now truth value of Q. Now if one odd number is there, if this n is what? Odd, then its square is also odd. And subtraction of two odd number is always what? Even. But they are saying that subtraction of two odd number is odd. It is not possible. Just consider one odd number is 11 and second odd number is 9. 11 minus 9 will be equals to what? 8. So 11 minus 9 will be equals to 2. So 11 minus 9 is 2. 2 is what? Even. For every two odd number, if we'll check, the difference will be always what? Even. So that's why here we can say that truth value of second part is false. And in case of or, in case of and, means here two parts are connected by what? And. In case of and, if at least one statement is false, truth value of and will be what? False. So here Q is false, so that's why we can say that truth value of P and Q will be what? False. Now observe the example number 3. In this example, what is the given statement? There exists n belongs to n, means there exists at least one element in natural number such that n plus 5 is greater than what? 10. If at least one natural number satisfies this condition, we can say that it is true, and if not a single natural number satisfies this condition, at that time we can say that false. Let us consider the value of n is equals to 1. So 1 plus 5 is what? 6. 6, is it greater than 10? No, 6 is not greater than 10. So let us consider value of n is equals to say 6. 6 plus 5 will be equal to 11, and 11 is what? Greater than 10. Means one natural number satisfying, and every natural number which is greater than 6 satisfies this condition. That's why we can say that truth value is what? T. If at least one statement, if at least one natural number satisfies this condition, at that time we can say that statement is what? True. And here many natural numbers satisfies this condition. Now observe the example number 4th. What is the statement? The square of any even number is odd. We have denoted it by what? Denoted it by P. The square of any even number is odd. And second part, what is the second part? The cube of any odd number is odd. That part we have denoted by Q. Means first part we have denoted by P, and second part we have denoted by Q. And these two parts are connected by OR. So that's why we can say that P or Q will be the symbolical representation. Once the symbolical representation is known to us, try to find out truth value. First we are finding truth value of P. The square of any even number is even, but they have given odd, means it is false. And second part, Q, the cube of any odd number is odd. Consider any odd number, you will come to know that its cube is also what? Odd. That's why we can say that truth value of Q is true. Now here symbolical representation means what? P or Q. P or Q is the symbolical representation of given statement. If symbolical representation is false, means statement is false. If symbolical representation means symbolical representation is true, means given statement is true. So here in case of OR, at least one statement is true, the result will be what? True. So here one statement is true, that's why we can say that truth value of P or Q will be equal to true. So in this way we have got the truth value of this statement. Now observe the example number 5th. What is the statement? In triangle ABC, if all sides are equal, then its all angles are equal. Means first part is what? In triangle ABC, all sides are equal. In triangle ABC, all sides are equal. And second part, in triangle ABC, all angles are equal. Second part we have denoted by Q. Means, and here two parts are connected by what? If then. Means its symbolical representation is P implies Q. Isn't it? Once the symbolical representation is known to us, to find out its truth value, find out truth value of P and Q. What is P in triangle ABC? All sides are equal. Then its all angles are also equal. Means here P is true and Q is true. If both the statements are true, then truth value of P implies Q will also be equals to what? True. Means if first part is also true and second part is also true, at that time implication is also what? True. In this way we have got the truth value of this statement. Now observe the 6th example. In this 6th example, means last example from this question. So for every n belongs to n, n plus 6 is greater than what? 8. Means we have to check that every natural number satisfies this condition or not. If at least one natural number does not satisfy this condition, we can say that truth value is false, because they are saying that every natural number satisfies this condition. This notation means this quantifier is read as what? For every. So let us check whether every natural number satisfies this condition or not. Let us begin with the first natural number 1. 1 plus 6 is what? 7. And 7 is not greater than 8, means 1 does not satisfy this condition. Even 2 also does not satisfy this condition. But remaining natural number 3, 4, 5, 6 satisfies this condition. Means for 2 natural number, this condition is not satisfying. So we cannot say that every natural number satisfies this condition. Means truth value of the truth value is what? F. In this way, we have got the truth value of this statement.